So now we'll actually go ahead and calculate a confidence interval with this new distribution. So a 1 minus alpha 100% confidence interval, remember that's your confidence level, it's a percentage between 0 and 100, for the mean is going to be x bar plus or minus a t-value times your standard deviation of the sampling distribution. So that's going to be x bar plus or minus t alpha over 2, and then we're using s divided by root n instead of sigma, because we only know the sample standard deviation. So this is small sample, and we only know sample standard deviation. And this is the shorthand, remember, for point estimate minus the margin of error to point estimate plus the margin of error. So our confidence interval requirements here are that our sample is randomly selected from the population of interest, and then the distribution of the population is approximately normal, or n is greater than or equal 30. And here when we're doing a t-interval, our sample size is not greater than or equal 30. So we're assuming approximately normal. So here we're going to compute a 99% confidence interval. So that means alpha is 0.01. And if a random sample of size 28, so n is equal to 28, yields x bar is 58.3, s is 4.1. So we first want to compute our margin of error. To get that, we need that t-value. So if alpha is 0.01, then alpha over 2 is going to be 0.01 divided by 2, 0.005. So then our t-value is going to be t.005. And then n is 28, so our degrees of freedom are going to be 28 minus 1, 27. So that t-value is going to be inverse t. And then we want to do the left area, so the area to the right of that t-value there is 0.005. The left area is going to be 0.995. And then 27 is our degrees of freedom. Let's go ahead and put that in the calculator. So second variables, inverse t is number 4, 0.995, degrees of freedom, 27, 2.77. So now let's go ahead and compute our margin of error. So that's this part right here. So that's going to be our t alpha over 2 times s over root n. So that's going to be 2.77. And then our sample standard deviation is 4.1. And we are dividing by square root of the sample size, 28. Let's go ahead and compute that on the calculator. So 2.77 times 4.1 over root 28. And that gives us 2.15 to 2 decimal places. So that's our margin of error. We add and subtract that to our point estimate, which is our sample mean. So our lower bound is going to be our sample mean minus the margin of error. So we're going to take that 58.3 and subtract the 2.15. And then our upper bound will be the sample mean, the point estimate, plus the margin of error. So that's going to be our 58.3 plus 2.15. So let's compute those on the calculator. So 58.3 minus 2.15, 56.15. And then 58 and 2 would be 60.45. So our 99% confidence interval is going to be 56.15 to 60.45. And our interpretation is that we are 99% confident that our population mean is between 56.15 and 60.45. Now, we can verify our work on the TI-84 calculator using the t-interval function. So to do that, we want to go to the stat menu, tests, and then t-interval is number 8. And we are using stats as opposed to the original data. So our x bar value was 58.3 and our standard deviation 4.1. So 58.3, S is 4.1. Our sample size was 28 and our confidence level 99%. And 56.15 to 60.45 if we round to 2 decimal places. And that's exactly what we got here.